Welcome back. In this segment, we're going to trace the iterative method on the second example. So let's consider the function f of n equals 1 if n is equal to 0, and f of n equals 2 times f of n minus 1 plus 1 when n is positive. Let's make sure we understand this recursive definition by computing the first few values of f. So f of 0 is 1 by definition. F of 1 is 2 times f of 0. 2 times 1 plus 1 is 3. F of 2 is 2 times 3 plus 1 is 7. F of 3 is 2 times 7 plus 1, 15. F of 4 is 2 times 15 plus 1, that's 31. F of 5 is 2 times 31, that's 62, plus 1 is 63. Now we could keep going on like this all the way up to f of 10. But instead, we want to apply the iterative method to convert this recursive definition into a closed form formula for f. Now remember, the first step is to compute a few values of f starting at the base case. So f of 0 by definition is 1. F of 1 is 2 times 1 plus 1, which is 2 plus 1. F of 2 is 2 times f of 1 plus 1, and f of 1 is 2 plus 1 now. So we can replace and get 2 times 2 plus 1, and when we multiply that, we get 2 squared plus 2 plus 1. Notice I'm not computing the final values of f of 1 and f of 2 here. I don't really care about the final value. What I care about is to identifying a pattern. And maybe you can see it emerge here in the computation. Let's do one more. What is f of 3? Well, f of 3 is 2 times this sum plus 1. When you multiply it, you get 2 to the power 3 plus 2 squared plus 2 plus 1. Now, I think the pattern is pretty clear. F of n seems to be the sum of all the powers of 2 from 0 to n. So 2 power 0 plus 2 power 1 plus ... 2 power n. Now let's write this sum using our summation notation. Sum of 2 to the power I for I equals 0 to n. Now we already know the formula, or at least you should know the formula. The final expression for this summation is 2 to the power n plus 1 minus 1. Now again, the next step, or the last step in the iterative method, would ask you to prove that this expression is indeed a closed form formula for f of n. Here I just wrote it without proving it. Let's assume we're convinced it's correct, and let's use it now to compute f of 10. Well, f of 10 is going to be 2 to the power 11 minus 1. 2 to the power 11 is 2 to the power 10, that's 1024, you got it, times 2, that's 2048, minus 1 is 2047. Notice not only you don't need a calculator, but you can do it pretty fast.